Okay, first of all today we're going to look at some friction on inclined planes. So last lesson we looked a little bit at friction and we looked at the fact that the maximum friction was equal to mu r, and we looked at it just on kind of boxes and particles sitting on flat planes. So we're going to look at some on inclined planes today. I'm going to suggest that you pause the video and just copy down the question, and as I'm going through it, just pause it as and when you need to stop to copy. So this question says, a box of mass 10 kilograms is at rest on a rough slope inclined at 33 degrees to the horizontal. So my first step, if I saw this, would be to draw a little picture. So that's my inclined plane with an angle of 33 degrees to the horizontal. And I've got a box on it. Let's draw a little box. There we go. Right, then it says, a force of magnitude 18 newtons acts on the box at an angle of 20 degrees above the slope. So if this box is sitting in the slope, it's going to want to slip down. So that's going to be going up the slope, the force, isn't it? So if that's kind of parallel to the slope, the force that's holding it will be going this way, 18 newtons. And this angle is going to be 20 degrees. It says calculate the coefficient of friction. So we're going to have R, aren't we? And we are going to have a mass of the box, 10g. Right, there's going to be some friction here. If this box is about to move, it's about to move down the slope. So friction always opposes motion, so the friction's going to go up. So my friction's going to be going that way. That's going to be my frictional force F. And once we've got that, we just need to resolve our forces. So just like we did before, I'm going to start by resolving, let's go parallel to the plane. And I'm going to resolve going upwards. So if I resolve going up, I've got, in fact, I've not filled in all my forces, have I? That force, if that's 33 degrees, that's going to be 10g cos 33, and that's going to be 10g sine 33. And then this force, I'm going to have one here, one here. I'm going to have an 18 cos 20 and an 18 sine 20 in there. It's a little bit difficult to see, but that's all our forces. So if I'm resolving parallel to the plane going up my plane, I've got F, and I've got an 18 cos 20. And because I'm in equilibrium, not moving, that must be equal to the downwards one. Or I could put minus downwards equals 0. And from that, I can now work out F, I hope. F will simply be 10g sine 33 minus 18 cos 20. And if I put that into my calculator, F's coming out being 36.46 newtons roughly. Once I've resolved parallel, I'm then going to resolve perpendicular. I'm going to go that way as positive. So if I'm going up that way, going that way, I've got R. Going that way, I've also got 18 sine 20. And then minus downward equals 0 because it's an equilibrium, or up equals down 10g cos 33. And from that, I can work out R. I'll just do 10g cos 33 minus 18 sine 20. That gives me R as being 76.03. And then the question's asking me to find mu. So remember from last lesson, the formula is that max friction equals mu times R. So we know it's on the point of slipping, so this friction must be maximum. And that equals mu times 76.03. So if I divide by 76.03, I get that mu equals 0.48 to 2 decimal places. Right, once you've copy that down and you're happy with that, in your textbooks, I'd like you to have a go at page 444, exercise 2.3.